Hello everybody and welcome to the video notes for day 3. Now we're on page 3 and in this video I'm going over number 5, number 7, and number 9. Let's start with number 5. Let's read the question. This table contains equivalent ratios between x and y, and here's the table, and what it's asking us for is, what is the missing value in the table? Whenever you have a table and you're trying to figure out the blank spaces, you just want to take a look at it and look for the patterns. You can either look for how things are changing, going up and down, or what the relation is as you look across. In this case, let's take a look at how these numbers are related going across. 2 to 6, 3 to 9, and 7 to 21. And I want to check, are we multiplying by the same number each time? In this case, we are. So I ask myself, 2 times what is equal to 6? 2 times 3 is equal to 6. Okay, that might be the pattern. Let's check the next one. 3 times 3 is also equal to 9. 7 times 3 is equal to 21. So now I know the pattern is y is always 3 times as many as x. So that means if 5 times 3 would be 15, using that same pattern, so 15 is my missing value. Okay, you can use that same strategy at this table here, try to find the pattern. Now I'm going to go over number 7. Juliana is baking a cake recipe that requires 3 cups of butter for every 9 cups of flour. If Juliana only has 6 cups of flour, how many cups of sugar will she need? Well, in this case, for this ratio, we can set up a table to stay organized. So we have cups of butter, so I'm going to use a B for butter, and flour. I'm going to use an F for flour. And it first tells us for every 3 cups of butter, so if we have 3 cups of butter, we need 9 cups of flour. So my ratio is 3 to 9. And then it's saying if Juliana only has 6 cups of flour, so we have a 6 here, what would have to be the amount of butter? So just like we did in this problem, you can look at the two numbers and figure out what is the relationship of this ratio, what's the pattern? Well, I can see that whatever the butter amount is, the flour amount is 3 times as many. So then I can think to myself, well, if there's 6 cups of flour, what times 3 is equal to 6? Or I can go the other way, right? 9 divided by 3 is 3, or 6 divided by 3 is 2. So how many cups of butter, I'm sorry, I made a typo. This should not be sugar, that should say butter. How many cups of butter will she need? She needs 2 cups. 2 cups of butter. There's my answer. Okay, last one. Let's take a look at the number 9. It says, the ratio of girls to boys in the classroom is 5 to 3. Jennifer states that there must be exactly 2 more girls than boys in the classroom. Determine a number of girls and boys in the classroom to show that Jennifer's statement is false. Enter the number of girls in the first box. Enter the number of boys in the second box. Okay. Let's create another table so we can stay organized. What 2 things are we comparing in this ratio? It's girls and boys, and we know that the ratio is 5 to 3. So let's have girls on the left and boys on the right. And the first ratio that they give us is for every 5 girls, there are 3 boys. Okay. Now Jennifer states that there must be exactly 2 more girls than boys. In this case, that's true, right? If there's 5 girls and 3 boys, there's definitely 2 more girls than boys. But it's asking us to determine a number of girls and boys that have the same ratio where it's not 2 more girls than boys. Here's how we can do that. With ratios, what if we doubled the number of girls? That means 5 times 2 would give me 10. If we had 10 girls, how many boys would we have if the ratio is the same? Well, if we multiply this left side by 2, in order for the ratio to stay the same, we also have to multiply the right side by 2. And 3 times 2 is 6. So now, using the same ratio, if we had 10 girls, that means we would have to have 3 boys. And how many more girls than boys are there? There are now 4 more girls than boys. So these 2 amounts prove that Jennifer's statement is false because you could have 10 girls and 6 boys. Now, it asks us to put the number of girls in the first box. So I would put 10 as one possible answer, and the number of boys in the second box. So I would put 6 boys in the second box. That works. This is one possible answer. Another possible answer could have been, instead of times 2, you could have said, well, what if there were 3 times as many girls? So let's do 5 times 3. That would be 15. 15 girls. And then that would mean you would do boys times 3. 3 times 3 is 9. So you could also have 15 girls and 9 boys. That also works here. Or you could have done times 4 on both sides or times 5 on both sides, and whatever you get, those could go here, because those would also not be more than 2. That would work. Okay. And with that,
thank you so much for playing my game.